Imagine a sound so colossal, so far-reaching, that it could be heard across continents, a sound that could potentially shake the very ground we stand on. What if every single person on Earth, all 8 billion of us, joined hands in a symphony of sound, a synchronized clap that echoed through the atmosphere? Could the combined force of this global applause actually cause the world to tremble? Let's embark on a journey to understand the sheer power of sound, the physics behind a simple clap, and the potential consequences of amplifying that sound to an unprecedented scale. Our exploration will take us from the basic principles of sound waves to the hypothetical scenario of a planet-wide hand clap, examining the possible effects on our environment and our senses. Join me as we delve into the intriguing world of acoustics, exploring whether the collective might of human action could truly make the world shake. Throughout history, we've witnessed the awe-inspiring impact of collective human action. From monumental feats of engineering to powerful social movements, the combined efforts of individuals have shaped our world in profound ways. But what about the simplest of actions, like clapping our hands? Could this seemingly insignificant gesture, when amplified by billions, generate enough force to create tangible effects? To grasp the potential of such a phenomenon, we must first understand the fundamental nature of sound. Sound is essentially a form of energy that travels as waves through a medium, such as air or water. When we clap, the impact of our hands colliding creates vibrations that propagate outwards as sound waves. These waves carry energy, and the intensity of the sound, or its loudness, is determined by the amount of energy carried by these waves. Just as a gentle breeze might rustle leaves while a hurricane can topple trees, the intensity of sound waves dictates their capacity to cause physical changes. Let's delve into the hypothetical scenario of orchestrating a global clap, a synchronized moment where every individual on Earth participates in this simple act. Imagine the cacophony, the sheer volume of 8 billion pairs of hands coming together in unison. But would this chorus of claps be enough to create anything more than a fleeting, albeit incredibly loud sound? To answer this, we need to consider the way sound waves interact with the environment. When sound waves encounter objects, they can be reflected, absorbed, or transmitted through the object, depending on its properties. The Earth's atmosphere, for example, absorbs some sound energy, which is why sounds become quieter as they travel further from their source. Moreover, the Earth itself is not a perfectly rigid body. It vibrates and resonates at specific frequencies, much like a giant bell. To understand the potential impact of a global clap, we need to delve deeper into the science of sound waves. Imagine dropping a pebble into a still pond. You see ripples, waves spreading outward from the point of impact. Sound waves behave similarly, propagating outward from their source in all directions. However, instead of water molecules, sound waves are vibrations traveling through a medium like air. When you clap your hands, you're forcing air molecules together, creating a region of high pressure followed by a region of low pressure. This pressure difference travels outward as a wave. The frequency of these waves, or how many pass a given point per second, determines the pitch of the sound. The amplitude, or the intensity of the pressure changes, determines the loudness. A single clap generates a relatively small amount of energy, resulting in sound waves with limited amplitude. These waves lose energy as they travel through the air, eventually dissipating entirely. The energy dissipation of sound waves over distance is a crucial factor in our global clap scenario. Even if 8 billion people were to clap simultaneously, the energy from their individual claps would spread out in all directions. As this energy travels through the atmosphere, it would encounter countless obstacles, buildings, trees, mountains, all absorbing and reflecting some of that sound energy. Think about how sound behaves in an open field versus a crowded city. In an open field, sound can travel relatively unimpeded. In a city, however, sound waves are constantly bouncing off buildings, creating echoes and a muffled soundscape. On a global scale, the Earth's diverse terrain and atmospheric conditions would act as a massive sound dampener. Furthermore, the Earth's atmosphere itself absorbs sound energy, converting it into a tiny amount of heat. Given the energy dissipation factors, could a global clap even be heard around the world? The answer is likely no. The loudest sound ever recorded was the eruption of Krakatoa in 1883. This volcanic eruption produced sound waves so powerful they were heard thousands of miles away and circled the globe multiple times. However, even this cataclysmic event didn't result in a single continuous sound wave encircling the Earth. While a global clap would involve far more sound sources than a single volcanic eruption, the individual contributions would be vastly smaller in scale. The combined energy, though initially immense, would be quickly dispersed and absorbed by the atmosphere and the Earth's surface. It's far more likely that a global clap would create a cacophony of sound localized to individual regions rather than a single cohesive sound wave traveling around the planet. But what about the Earth itself? Could the combined energy of a global clap cause the planet to vibrate? Every object has a natural frequency at which it vibrates, known as its resonant frequency. When an object is subjected to vibrations matching its resonant frequency, the amplitude of those vibrations increases dramatically. This phenomenon is why a wine glass can shatter when exposed to a specific musical note. The Earth, despite its immense size, also has resonant frequencies. Scientists have observed a constant, low-frequency vibration of the Earth known as the hum. This hum is thought to be caused by a variety of factors, including ocean waves, atmospheric pressure changes, and even the movement of the Earth's crust. Could a global clap, with its vast energy, potentially excite one of Earth's resonant frequencies and amplify this hum? While the idea of humans collectively shaking the planet is captivating, the reality is far less dramatic. The Earth's resonant frequencies are extremely low, far below the range of human hearing. To put things into perspective, consider the energy released by earthquakes. Earthquakes are caused by the movement of tectonic plates, releasing enormous amounts of energy in the form of seismic waves. The energy released by a magnitude 9 earthquake, for example, is roughly equivalent to the detonation of 25,000 atomic bombs. In contrast, the energy generated by even 8 billion people clapping simultaneously would be minuscule compared to the forces at play in natural disasters like earthquakes. While a global clap might be audible locally and create a brief localized increase in sound energy, it would be far too weak to trigger any noticeable seismic activity. We've established that a global clap wouldn't cause earthquakes or send shockwaves around the planet. However, the sheer volume of sound generated by such an event is still worth considering. The decibel scale measures sound intensity, with higher decibel values representing louder sounds. A whisper might register around 30 decibels, a normal conversation at 60 decibels, and a rock concert at 120 decibels. Now imagine 8 billion people clapping simultaneously. Even if we generously assume an average clap generates 100 decibels at the source, and even accounting for sound dissipation, the combined volume would be astounding. However, the experience wouldn't be uniform across the globe. Those in densely populated areas would experience a significantly louder sound than those in remote regions. Prolonged exposure to sounds above 85 decibels can cause hearing damage, and sounds above 120 decibels are perceived as painful. A global clap, even with atmospheric absorption, could potentially exceed these thresholds in many locations. Let's try to quantify the potential volume of this global clap, acknowledging the immense challenge in accurately modeling such a complex scenario. If we assume an average clap produces 100 decibels at the source, and we have 8 billion sources, a simple addition wouldn't give us an accurate picture. Sound doesn't combine linearly. Instead, we use a logarithmic scale. For every doubling of sound sources, the total sound pressure level increases by approximately 3 decibels. With 8 billion claps, we're talking about an astronomical number of doublings. Even with these mitigating factors, the resulting sound pressure level from a global clap would likely be well above 100 decibels in many areas, potentially exceeding 120 decibels in densely populated regions. To put that into perspective, that's louder than a jet engine at close range. As we approach and exceed 120 decibels, we enter the realm of pain for the human ear. At these levels, sound is no longer just an auditory experience, it becomes a physical sensation. The delicate mechanisms within the inner ear responsible for translating sound waves into electrical signals for the brain to interpret can be overwhelmed and even damaged by prolonged exposure to such intense sound. A global clap reaching these decibel levels wouldn't cause instant deafness, but it could lead to temporary hearing loss, tinnitus, ringing in the ears, or exacerbate existing hearing conditions. Furthermore, the discomfort wouldn't be limited to our ears. High-intensity sound can also cause physical sensations like pressure in the chest, headaches, and even nausea. In reality, if 8 billion people were to clap, there would be a slight variation in timing. This slight asynchrony would actually help mitigate the peak volume, as the sound waves wouldn't perfectly align and amplify each other. While the auditory impact of a global clap is the most obvious consideration, it's worth pondering how such an event might affect our other senses. Could we feel the sound waves as vibrations in the ground? Could the massive displacement of air create noticeable wind currents? The answer is likely a subtle yes. While the ground vibrations wouldn't be on par with an earthquake, those in close proximity to large groups of people clapping might feel a slight tremor. Similarly, the displacement of air by billions of hands moving in unison could create localized, albeit very faint, air currents. These sensations wouldn't be dramatic or widespread, but they highlight the interconnectedness of our senses and the environment. A sound event of this magnitude wouldn't just be heard, it would be felt, albeit subtly, as a ripple through the very fabric of our surroundings. Humans wouldn't be the only species experiencing this global sonic event. Animals, often more attuned to their acoustic environments than humans, could perceive the global clap quite differently. For some, it might be a brief annoyance, a sudden disruption to their routines. For others, it could trigger fear responses, or even interfere with essential behaviors. Consider animals that rely on sound for navigation, like bats or whales. A sudden global surge in sound energy could momentarily disrupt their echolocation abilities, potentially disorienting them, or even leading to collisions. Animals that communicate acoustically, from birds to insects, might find their signals lost in the cacophony, hindering their ability to find mates, defend territories, or alert others to danger. While the global clap wouldn't be a catastrophic event for the animal kingdom, it serves as a reminder that our actions can have unintended consequences for other species. The global clap, while intriguing in its hypothetical nature, highlights the interconnectedness of our world and the potential for unintended consequences from even seemingly insignificant actions. Just as the flap of a butterfly's wings is said to have the potential to influence weather patterns on the other side of the globe, a global clap could trigger a cascade of subtle, unpredictable effects. Could the sudden change in air pressure from the clap affect weather patterns in a localized area? Could the mass displacement of air carry pollen or other airborne particles further than usual, influencing plant life or even triggering allergies in susceptible individuals? While these are highly speculative scenarios, they illustrate the complex web of cause and effect that governs our planet. The global clap serves as a thought experiment, urging us to consider the ripple effects of our actions, however small. While we've explored the potential impacts of a global clap, it's important to acknowledge the logistical impossibility of such an event actually occurring. Coordinating 8 billion people across different time zones, cultures, and levels of accessibility to technology presents an insurmountable challenge. Even if we could somehow communicate the idea to every individual on Earth, ensuring simultaneous participation would be impossible. The speed of light, while incredibly fast, is still finite. This means that even with instantaneous communication, there would be a delay of several milliseconds between different parts of the globe receiving the signal to clap. This seemingly small delay would be enough to disrupt the synchronization, preventing the perfect alignment of sound waves needed to achieve the maximum hypothetical volume. The global clap, then, remains firmly in the realm of thought experiment, a testament to the limits of human coordination on a global scale. While a literal synchronized global clap might be impossible, the concept itself holds a certain poetic appeal. It represents a moment of shared human experience, a fleeting instance where billions of individuals across the globe participate in the same simple action. Even if the sound waves themselves couldn't circle the Earth, the sentiment behind the gesture could resonate far more powerfully. Imagine the sense of connection, the feeling of being part of something larger than oneself, if even for a brief moment. The global clap, in its impossibility, becomes a symbol of human unity, a reminder that despite our differences in language, culture, and geography, we share a common bond as inhabitants of this planet. While we may never hear the Earth reverberate with the sound of 8 billion clapping hands, the idea itself sparks our imaginations and encourages us to consider the power of collective action, even in its most symbolic forms. Our planet is a dynamic entity, constantly in motion, shaped by forces both internal and external. The Earth's rotation creates day and night, its orbit around the Sun dictates the seasons, and beneath our feet, tectonic plates shift and collide, shaping continents and triggering earthquakes. This constant dance of forces creates a background hum, a subtle symphony of vibrations that permeates our planet. From the crashing of waves on the shore to the rumble of distant storms, we are surrounded by natural phenomena that generate vibrations traveling through the Earth's crust. Even human activities, from the movement of cars and trains to the construction of cities, contribute to this constant tremor, albeit on a much smaller scale. This background vibration is a testament to the Earth's dynamism, a constant reminder that our planet is not a static sphere, but a living, breathing system in perpetual motion. Against this backdrop of natural forces, the question arises, could a global clap, a brief but intense burst of human-generated sound energy, make a noticeable contribution to this symphony of vibrations? To understand the impact of a global clap on Earth's vibrations, we need to delve into resonance. Resonance occurs when an object vibrates at its natural frequency, amplifying the vibrations. Think of a child on a swing set. A push in sync with the swing's frequency sends the child higher. Earth has natural frequencies determined by its size and composition. Seismic waves can excite these frequencies, making Earth vibrate. Could a global clap align with Earth's frequencies and amplify vibrations? The likelihood is exceedingly small. Earth's frequencies are low, and a global clap's energy distribution would need to be precise. Imagine 8 billion people simultaneously clapping their hands. The combined energy, though dispersed over a vast area, would be undeniably immense. Could this collective action, this global handshake, be enough to tickle the Earth's surface, to create a noticeable blip in the planet's constant hum of vibrations? While the image of humans collectively nudging the Earth is captivating, the reality is that the planet's sheer mass and inertia would dampen any significant impact from such an event. The Earth weighs roughly 6.6 sextillion tons. That's a 6 followed by 21 zeros. This immense mass acts as a buffer, absorbing and dispersing energy from external forces. Furthermore, the energy from a global clap would be spread out over the Earth's entire surface area, further reducing its impact at any specific point. It's like trying to move a boulder by blowing on it. The force applied is simply too diffuse and too weak to overcome the object's inertia. Section 4. Seismic waves versus sound waves, a matter of scale. To grasp the difference in scale between a global clap and events that can genuinely shake the Earth, we need to compare the energy levels involved. Seismic waves, generated by earthquakes and volcanic eruptions, release enormous amounts of energy as they travel through the Earth's interior. The energy released by a magnitude 9 earthquake, for example, is roughly equivalent to the detonation of 25,000 atomic bombs. In contrast, the energy generated by even 8 billion people clapping simultaneously would be minuscule compared to the forces unleashed by these geological events. A global clap might create a local spike in sound energy, but this energy would quickly dissipate as it travels through the atmosphere and interacts with the Earth's surface. The energy from a global clap, while impressive in its human-generated scale, would be like throwing a pebble into a raging river. It might create a momentary ripple, but it wouldn't alter the river's course or disrupt its flow in any significant way. Section 5. The power of perspective, zooming out to the Earth's scale. Our intuition often struggles to grasp the vastness of the Earth and the immense forces that shape it. From our human perspective, a global clap involving billions of participants might seem like an event capable of generating planet-altering energy. However, when we zoom out to the Earth's scale, our perspective shifts dramatically. Imagine shrinking the Earth down to the size of a basketball. On this scale, the tallest mountains would be barely perceptible bumps, and the deepest oceans would be thin films of water. Humans at this scale would be microscopic, invisible to the naked eye. A global clap on our basketball-sized Earth would be like a gentle breeze brushing against its surface. This shift in perspective highlights the importance of considering scale when evaluating the potential impact of human activities on the Earth. While our collective actions can have significant local and even regional consequences, their effects on the planet as a whole are often dwarfed by the immense forces of nature. Section 6. Unintended Consequences. The Law of Unforeseen Ripple Effects. The global clap thought experiment, while ultimately concluding that such an event wouldn't cause earthquakes or noticeably shake the planet, serves as a valuable reminder of the interconnectedness of our world and the potential for unintended consequences. Even seemingly insignificant actions, when amplified by billions of participants, can have ripple effects that extend far beyond their intended scope. The global clap, with its potential to generate sound levels exceeding the threshold of human pain and disrupt animal communication, highlights the importance of considering the broader ecological and societal impacts of our actions. It's a reminder that we live in a complex web of interconnected systems, where even seemingly harmless activities can have unforeseen and far-reaching consequences. The global clap, in its hypothetical nature, encourages us to approach our interactions with the planet with a sense of humility and awareness, recognizing that even our smallest actions can contribute to a larger, interconnected web of cause and effect. Section 7. The global clap as a metaphor, our interconnected world. While a literal synchronized global clap might be logistically impossible, the concept itself holds a certain metaphorical power. It serves as a potent symbol of human interconnectedness, a reminder that despite our geographical, cultural, and linguistic differences, we share a common bond as inhabitants of this planet. The global clap, in its impossibility, challenges us to imagine a world where such a feat of global coordination might be possible. A world where communication barriers crumble, and humanity unites in a moment of shared experience. It's a utopian vision perhaps, but one that highlights the power of collective action and the potential for human unity on a global scale. The global clap, in its metaphorical sense, transcends the realm of physics and enters the realm of human aspiration, urging us to strive for greater understanding, cooperation, and shared responsibility for our planet. Section 8. Beyond the hypothetical real-world examples of collective impact. Collective human actions have profoundly impacted our planet. From the ozone layer depletion to the climate crisis, our actions can also drive positive change. Phasing out harmful substances, embracing renewable energy, and conservation efforts show our potential for a sustainable future. The global clap symbolizes the power of collective action. Our choices, amplified by billions, shape our planet's future. Let's harness this power for a just and sustainable world. Our place in the cosmic order. Our exploration of the global clap has taken us far beyond the simple act of clapping our hands. We've delved into the depths of the Earth and contemplated the vastness of the cosmos. This journey reminds us of our place within the grand scheme of things. We are but one species among countless others in the vast universe, yet we possess a remarkable capacity for curiosity and understanding. This capacity for wonder sets us apart as a species. It drives us to explore the unknown and unravel the mysteries of the universe. Section 2. The Power of Curiosity. Unveiling the universe's secrets. The question of whether a global clap could shake the Earth might seem trivial, even absurd. Yet, it's precisely this kind of inquiry that often leads to profound discoveries. Asking what if opens our minds to new possibilities and transformative journeys. Just as a child's question about the sky leads to understanding light, a whimsical question about a global clap can lead to discovery. Uncovering principles of acoustics, geology, and psychology. The pursuit of knowledge is a winding road of unexpected discoveries. Embracing curiosity fuels scientific progress and reveals the wonders around us. Section 3. Beyond the Clap, Exploring the Frontiers of Sound. Our exploration of the global clap has only scratched the surface of the fascinating world of sound. From the intricate workings of the human ear to the use of sound waves in medical imaging and materials science, the study of acoustics is a rich and ever-evolving field with far-reaching implications. Scientists are constantly pushing the boundaries of our understanding of sound, exploring its potential applications in fields as diverse as communication, medicine, and even energy production. Researchers are developing new ways to manipulate sound waves to create acoustic levitation devices, to deliver targeted drug therapies, and even to generate electricity from vibrations. The global clap, while a hypothetical scenario, serves as a springboard for exploring the vast potential of sound and its role in shaping our understanding of the world and our place within it. Section 4. Your turn to explore. Questions to ponder. As we conclude our journey into the hypothetical realm of the global clap, I invite you to continue the exploration on your own. Here are a few questions to ponder, to spark your curiosity and encourage you to delve deeper into the wonders of science. What other collective human actions, besides clapping, could potentially have a noticeable impact on the Earth, even if only on a local scale? How do animals with different hearing ranges and sensitivities perceive the world around them compared to humans? What are some of the most surprising or unexpected applications of sound technology being explored by scientists today? If you could orchestrate a global event involving every human on Earth, what would it be and what message would you hope to convey? These are just a few starting points to ignite your imagination. The beauty of science lies in its ability to inspire endless questions and lead us down unexpected paths of discovery. I hope you've enjoyed this exploration of the global clap and the fascinating world of acoustics. Now, I'd love to hear from you. Share your thoughts on the questions posed or any other insights sparked by our discussion in the comments section below. If you're as captivated by the wonders of science as I am, be sure to subscribe to this channel for more explorations of the universe and its many mysteries. Together, let's continue to ask questions, challenge assumptions, and unravel the secrets of the cosmos, one intriguing query at a time. So would the world shake if everyone clapped at once? Probably not. The energy would be absorbed by the atmosphere and Earth's mass, no tectonic shifts or continent rearrangements would occur, but the question itself sparks wonder and curiosity. It's this spirit of inquiry that drives us to explore the unknown. The global clap in its impossibility serves as a potent reminder that even the most seemingly insignificant actions can have far-reaching consequences. Every sound we make, every step we take, sends ripples of energy out into the world, interacting with the environment and influencing the delicate balance of our planet's systems. While a single clap might be a fleeting whisper in the grand symphony of Earth's soundscape, the collective actions of billions of humans create a chorus that resonates throughout the planet. From the air we breathe to the resources we consume, our impact on the Earth is undeniable. The global clap, though silent in its realization, echoes with a profound message of interconnectedness and shared responsibility. It's a reminder that we are not isolated actors on a static stage, but rather integral parts of a dynamic and interconnected web of life. Our actions, however small, have the potential to create ripples that extend far beyond our immediate perception, influencing the delicate balance of ecosystems, the health of our planet, and the well-being of generations to come. So let the silence of the unrealized global clap serve as an invitation to wonder, to explore, and to approach our world with a renewed sense of curiosity and responsibility. Let it remind us that even in the absence of earth-shattering results, the pursuit of knowledge, the questioning of assumptions, and the exploration of the unknown are endeavors worthy of our time, our energy, and our collective imagination. The universe is brimming with mysteries waiting to be unraveled. The Earth, our home, is a symphony of complex systems begging to be understood. And we, the curious inhabitants of this remarkable planet, have the capacity and the responsibility to keep asking questions, seeking answers, and striving to create a future where both humanity and nature can thrive in harmony. Thank you for joining me on this exploration of the global clap. May this journey inspire you to continue asking questions, to embrace the wonders of science, and to approach our world with a renewed sense of wonder and a commitment to creating a more sustainable and harmonious future for all.